Destinus tests new version of its long-range cruise missile system. European defense company Destinus has completed a flight test of its Ruta Block 2 precision deep strike system, validating a fundamentally redesigned launch architecture that allows the weapon to be stored, transported, and fired from sealed, containerized modules. The test confirmed the performance of two critical enabling technologies: an inline booster configuration and foldable wings and control surfaces. Onboard footage captured successful in-flight wing deployment during the launch-hand transition sequence. The shift from Ruta Block 1 to Block 2 represents a deliberate architectural overhaul rather than an incremental upgrade. The original Block 1 system uses wings attached before launch, two side-mounted boosters, and an open platform launcher. Block 2 eliminates each of those constraints. Wings fold for storage and deploy automatically after launch. The booster moves to an inline configuration. The entire system fits inside a sealed, containerized module, removing the need for open platform infrastructure. At the point of launch, that combination of changes expands the range of platforms and locations from which the weapon can be deployed and compresses the time required to get it into the fight. Tim Moser, Chief Technology Officer of Destinus, framed the test's significance directly. This test validates Ruta Block 2 and marks the transition from the current launch architecture toward a system designed for more flexible deployment and scalable long-range strikes. A more compact launch architecture improves transport, storage, packaging density, and integration flexibility across mobile, ground, fixed site, and maritime platforms. It also supports broader launcher compatibility and more scalable deployment concepts for long-range strike systems. A weapon system that can be stored and launched from a sealed module can be loaded onto trucks, ships, rail cars, or fixed installations without requiring specialized open platform launch infrastructure. At each site, it can be pre-positioned in dispersed locations, reducing the vulnerability that comes from concentrating strike capability in a small number of identifiable launch sites. Deployment timelines shrink because there is no assembly step. The weapon is ready inside its container, and the container is the launcher. Side-mounted boosters, as used on Block 1, add width to the weapon storage and transport footprint. Moving the booster inline behind or ahead of the main body rather than beside it brings the system's cross-section down to something that fits inside a standard containerized module. Foldable wings achieve the same result for the weapon's span. A system that flies on extended surfaces can be stored in a fraction of the volume when those surfaces fold flat. The earlier system has already demonstrated operational relevance and reached serial production at meaningful scale, giving Destinus real-world performance data and industrial experience before committing to the architectural changes embodied in Block 2. That sequence, fielding a proven system first, then redesigning for greater flexibility on top of a validated foundation, reflects a development approach that prioritizes demonstrated capability over paper specifications. Moser also pointed to the industrial model behind the program. The successful test also underscores the strategic value of Destinus' vertically integrated industrial model. Key subsystems were developed and manufactured in-house, enabling the industrial scaling that defense customers increasingly demand as European governments prioritize sovereign capability and supply chain resilience. Destinus' model offers a secure, independent path to cutting-edge long-range precision strikes. Vertical integration, developing and manufacturing critical subsystems internally rather than sourcing them from external suppliers, gives Destinus direct control over production rates, quality standards, and the supply chain vulnerabilities that have plagued defense programs dependent on single-source components. For European governments that have spent the past several years watching supply chain fragility disrupt everything from ammunition production to semiconductor availability, a supplier that manufactures its own critical subsystems offers something procurement offices increasingly value: reliability at scale under pressure. The Ruta Block 2 test lands at a moment when European governments are conducting urgent reassessments of their long-range strike requirements. Russia's sustained missile and drone campaign against Ukraine has demonstrated what the absence of deep strike capability costs a defending force, and has focused European defense ministries on the gap between what they currently field and what modern conflict actually demands. Long-range precision strike is no longer a capability reserved for great power competition planning. It is a requirement that the war in Ukraine has made immediate and concrete. Destinus has not disclosed the range warhead or guidance specifications of the Ruta system publicly. What the company has confirmed is that Block 1 is in serial production and that Block 2 has now completed a successful flight test validating its new launch architecture.